Yes, ma'am.
Yes.
Good morning, everyone.
Good morning, sir.
A warm welcome to our Honorable Director, Professor Dr. Satish Ubade, sir, distinguished faculty members, and the student of Matrix. Dear student, Matrix is committed to enhancing the management competencies of MBA graduates by imparting contemporary knowledge and focusing on the latest advancement in the field of management. In alignment with this vision, our director, Professor Dr. Satish Ubade, has initiated the four dimension session, a distinguished platform that brings together eminent experts from academy and industry to share their valuable insights, thereby enriching student learning and employability. Today, it is my great honor and privilege to introduce a personality who has inspired many students and professionals through her knowledge, academic excellence, and remarkable contribution to teaching and research. I invite Dr. Smita Rohidas Temgire, a distinguished academician, researcher, and mentor with more than 20 years of rich experience in education, research, and software development currently. She is serving as Associate Professor at PVG's College of Engineering and Technology and GKP Institute of Management. Dr. Temgire holds a PhD in Business Management and possesses expertise in research methodology, marketing research, management information system, IT for management, and service marketing. Her vast academic experience has enabled her to contribute immensely to postgraduate education and research guidance. She has made significant contribution to academic research and has published numerous papers in Scopus Index, APDC, and reputed international journals on contemporary themes such as digital transformation, innovation management, leadership profiling, and sustainability. Apart from teaching and research, Dr. Timgire has actively contributed to curriculum development, academic administration, mentoring, and organizing various academic and co-curricular initiatives. A dedication towards nurturing young minds and promoting research excellence is truly inspiring. So, what makes her journey even more remarkable is her unique blend of industry and academic experience, having worked in software development before moving into academia, which gives her balanced practical and theoretical perspective of management education. I'm sure today's session will be full of learning, motivation, and valuable insight for all of us. So, without taking much time, let us welcome an inspiring academician, an accomplished researcher, and a wonderful mentor. Please join me in warmly welcoming Dr. Smita Rohidas Temgire.
Thank you so
Welcome,
much,
ma'am.
sir, for such a wonderful introduction. Thank you, Giri sir, and thank you, Director Dr. Ubale sir, for providing me this opportunity to deliver a session on hypothesis. Now, without wasting time, good morning, all students. We'll start with our session. We'll see first, sir, can you share the screen or
Just
PPT?
a second. Before hand over to ma'am, I invite all students to turn on their cameras as we will be taking a group photograph.
Done, sir. Done.
Okay, Rohit sir. Thank you, Rohit sir. Once again, a warm welcome to Dr. Smita Timgire ma'am. Over
Thank
to
you
you,
so much.
ma'am, for the session.
Okay, so sorry, just give me a right to share my PPT.
Yes, ma'am. Yes. Just a second. Ma'am, can you
Yes,
please
sir.
share the PPT?
So I've shared on your email also, sir. Is
No,
it possible to you to share from your side?
मी तुम्हाला ऍक्सेस केलंय मॅम. जरी नाही झालं तर मग मी इथून करतो.
I'll check. So please share it from your side.
Okay,
Still
ma'am.
I'm unable to. Yeah.
Okay, okay. Okay, ma'am. You can
Okay, thank you so much, sir. Thank you.
Okay, ma'am.
So, dear students, this is what we are going to cover today. What is hypothesis? Then we'll see what are the characteristics of hypothesis, what are the functions of hypothesis, and then we'll see what are the various types of hypothesis. Then what are type 1, type 2 errors, testing procedures, and example. This is what we are going to cover today. Next slide, sir. Now, in short, see, in simple word, what do you mean by hypothesis? It's, in common terms, it is an assumption. Okay. So, in technical terms, it is a statement of proposition, supposition, or assumption. But which is to be, we don't know. Okay. At the beginning of the research, now we will assume that we all are researchers since we are studying this part. We'll assume all my students are researchers and they are going to conduct, say, in their project or say research project, whether it is field project or research project, you are going to face this step while conducting your research. Now, in technical terms, it is the statement of assumption, presumption, or supposition. Now, tell me one thing. Your students will try to make it interactive. Now, when I say it's a statement of assumption, presumption, or supposition, do you know at the beginning whether that assumption is correct or not? Whenever we assume anything, so do we have any idea whether it is true or false, or is it correct or not correct? Yes. Anyone who wants to answer, please unmute and answer. I want to make it interactive. Yes, students, anyone from your side? Very basic and simple question. When you are assuming anything at the beginning of researcher, we don't know, okay, whether it is true or false, or whether the assumption is correct or not. Okay, so that means we need to prove or disprove, or it will be proved or disproved after the analysis of the data, okay, or after analyzing the data. So in technical terms, hypothesis is a statement of prediction, supposition, preposition, or you can say presumption, okay, or which is stated to check whether there is a relationship or association between two or more variables. Okay, and it is to be tested, means at the beginning researcher does not know whether it is true or false, whether it should be accepted or rejected. So initially we don't know whether it is true or false. So it is a statement of proposition, supposition, prediction, presumption, which will be proved or disproved after the data analysis part. So it's unproven proposition. Next slide, sir. Yes. Okay. Now, moving to the characteristics of hypothesis, it must be conceptually clear, means there shouldn't be ambiguity while stating the hypothesis. One should not be able to draw different meanings. It should be very clear, and it should be stated in quantitative terms majorly. At your level, it should be quantity in terms of, or you can say in quantitative terms, it should be measurable, and it should be capable of being tested. One should be able to test by using different analytical techniques or t-test, or using different statistical tools. It should be, one should be able to test it. And also, if tested by different researcher, one should be able to come to the same conclusion. It should not give different results different times. Okay. So third characteristic, it should be stated in most simple terms, easy to understand for the readers. It should have empirical reference. Empirical means based on certain what you can say proof. Okay, one should be able to logically prove or disprove it based on the empirical evidence. There should be some evidence, and it must be specific. It shouldn't be vague. Whichever two variables, two or more variables should be stated clearly, whether you want to find out the relationship, association among whichever variables, those should be clearly mentioned in the statement of hypothesis. So hypothesis is basically a statement of assumption, presumption, proposition, supposition. Okay, you can use any word, and it should be related to available knowledge and techniques. Suppose researcher wants to prove or disprove or want to work on the hypothesis, the related knowledge, data or techniques should be available in the market to test or prove or disprove the hypothesis. It should be expressed economically using the correct terminology. Okay, so again, I'll repeat, there shouldn't be any ambiguity while stating the hypothesis. One should use correct terminology. There shouldn't be any ambiguity among the statements, and it should be logical. Definitely, one should be able to derive or come to any conclusion or result from the stated hypothesis or statement. Next slide, sir. Now moving on to the functions of hypothesis. Now, why hypothesis is required, or what are the functions of, is it necessary to state the hypothesis? Yes. To bring the clarity to the research problem. Now, when I say, for example, when I say factors affecting employee performance, okay, this is a clear statement. But in hypothesis, we go into more details. Now, which factors you are associating with the employee performance? For example, work culture is one of the factors. Then in hypothesis, one should state, researcher should state whether there is association between the work culture and employee performance or not. Or say salary is one more factor. Then one should state clearly in another hypothesis or the statement of presumption, you can say, or proposition, whether there is a relationship between salary and the employee performance. So from these statements, one will clearly come to know that the researcher is trying to find out the relationship between work culture and the employee performance. In second case, the employee is trying to find out the relationship between salary and the employee performance. This way, the hypothesis, these statements or the statements of hypothesis, they bring clarity to the research problem. What exactly the purpose of the research or the objective of the research, or for which problem the researcher is trying to find out the solution. Then it provides study with focus. Now, from these statements, one can clearly understand that researchers' focus is towards finding out whether the culture is affecting employee performance or not. Next is signifies what specific aspects of research problem is to investigate. Now I'll take the same example. Now in this example, what researcher is trying to investigate? He's trying to investigate whether culture is affecting the employee performance or not. Then what data to be collected and what not to be collected. Now if you are trying, the researcher is trying to find out the relationship between the performance, employee performance and the culture, then the data should be relevant, means the data related to organization culture should be considered, or data related to employee performance should be considered, and the other data shouldn't be missed, it should be focused. Then formulate the theory. Sometimes hypotheses are framed to formulate the theory. For example, suppose researcher wants to develop a theory related to behavior of human being. Then what he will do, or behavior of the employees of certain organization. Then he will try to study the behavior of the employees, or say human being. Okay, and then he will try to, now by observing the behavior, by studying the behavior, or by doing research on the different aspects of human behavior, the researcher can draw the theory from his research that in such and such situation, the employees exhibit such type of behavior, or human beings exhibit such type of behavior. Such theories can be developed by from the hypothesis. Then one should be enabled to conclude with what is true and what is false. Okay, hypotheses at the end are to be tested. Okay, see, the first step is the formation of hypothesis statement. After that, now as I told, it is the statement of proposition assumption. Okay, at the beginning, researcher does not know whether these statements are correct or not. Those should be tested. Okay, now how to test? By collecting the relevant information, those are tested, and performing certain statistical tests. Those are tested, and then the researcher can conclude whether those statements were true or false. At the beginning of research, whichever statements he or she framed in the hypothesis, those are true or false, can be concluded at the end. So next slide. So these are the functions of hypothesis. In short, they bring clarity to your research, okay, and they give focus. They provide focus to the study or the research, or to your problem statement. Next slide, sir. Now mainly, Aniket sir, please move to the next slide. Now here, we will be emphasizing more on the two types of hypothesis, that is null and alternative hypothesis. Working hypothesis is also there. Now null hypothesis, we'll see the example. It is the statement of negation, or say no significant difference between two or more variables. And alternative hypothesis is nothing but the statement which is exactly opposite to the null hypothesis, and which will show that there is significant relationship between two or more than two variables. Next slide, sir. We'll see with example. Now this null hypothesis is a statement of no difference, and which is usually denoted by HO, H0 or HN, you can say. And alternative hypothesis is denoted by, sir, please move to the next slide. Alternative hypothesis is denoted by HA or H1, you can say. And this is the statement which is exactly opposite to the null hypothesis. When I say null hypothesis, it is always, now it is usual practice that you will state the null hypothesis in terms of there is no significant difference between two variables or among two or more variables. And alternative hypothesis will be exactly opposite. That is, suppose I want to say, see, for example, when I say there is no significant difference between the work culture and employee performance. Okay, so now here I'm trying to find out the relationship between two variables. First one is work culture, and the second one is employee performance. And when I state null hypothesis, I will always state there is no significant difference, okay, or there is no significant relationship. Now, when I try to find out the relationship between work culture and, say, employee performance, the null hypothesis can be there is no significant relationship between work culture and employee performance. Now, again, I'm repeating, this is the statement of presumption, proposition, or assumption. We don't know whether it is true or false. That will be proved or disproved after the analysis part. Then alternate hypothesis for the same statement would be there is significant relationship between the culture, work culture, and the employee performance. Sir, I request you to move to the next slide, please. Next. Okay, now this is one more example. Population do not have any influence on the number of bank branches in a city or town. Okay. Now, there is one more style to present the same statement, that there is no significant influence of population on the number of bank branches in a town or city. Now, for the same, what will be alternative hypothesis? Exactly opposite of this statement. Population has significant effect on the number of bank branches in a town, or in other words, same statement can be reframed, which is more technical. That is, there is significant impact of population on the number of bank branches in a town or a city. Okay. So working hypothesis for the same is population influences the number of, this is the generic assumption we can say, population influences the number of bank branches in a town or a city. Okay, next, now we'll move to the types of hypothesis. Yes. Now, on your screen, you'll see there are two types of hypothesis. One is non-directional and another one is directional. Now, you'll see what is non-directional hypothesis and directional hypothesis. Now, for the statement that training has no impact on the productivity of the library staff. Look at this example. Now, in this statement, what I'm stating or what I'm assuming is that training has no impact. Now, when you say impact of anything, the impact can be positive or negative. Okay. Now, the alternative statement, alternative hypothesis for the same is training has an impact on the productivity of library staff. Now, here we are just stating that whether training has impact or no impact. Now, we are not saying the training has positive impact or negative impact. Now, in such cases, when the direction is not mentioned in the hypothesis. Now, in the first example, we are just saying whether training has no impact or no impact. In null hypothesis, we are stating that the training has no significant impact on the productivity of staff. Okay, we are not stating whether it is positive or negative, just stating the training has no impact, and in alternative we are stating that training has an impact on productivity of library staff. Now, such type of hypothesis or statements, they are called non-directional hypothesis. Why non-directional? Because in these statements the direction is not mentioned, whether training has created positive impact or negative impact. Another example we'll discuss, say, suppose advertisement, if we want to check whether advertisement has created impact on sales of a company. So how to frame null hypothesis for the same? we'll say the advertisement, there is no significant impact of advertisement on sales. Okay. Now this is null hypothesis, but whether it is directional and alternative hypothesis for the same, it will be the advertisement has created significant impact on the sales of a company or a product. Okay. Now here I am not mentioning whether it is the sale has been increased or decreased, or whether advertisement has created positive impact or negative. Now such statements, they are called non-directional hypothesis, wherein direction is not mentioned, whether it is increasing, decreasing, or it has created positive impact or negative impact. Now move to the second part of the statements. Okay, directional hypothesis, exactly opposite to non-directional hypothesis. Directional hypothesis are the hypothesis or the statements of assumption which will show the direction. Direction means whether the training has created positive impact or negative impact, or whether sales is increasing or decreasing due to advertisement. Now we'll read the second statement. The training has positive impact on the productivity of the library staff. Okay, that means here the direction is mentioned. Okay, what is the impact of training program? Positive. We want to check whether it has created positive impact or not. So that's why we are assuming initially in the hypothesis statement that there is significant positive impact on productivity of the library staff. Or it can be other way. The training program has created negative impact on the productivity of the staff. Okay, this way is also possible. Okay, so in both the cases, direction is mentioned. So such type of statements or hypothesis, they are called directional hypothesis. Clear? I hope all are able to understand the concept of non-directional and directional hypothesis. If you have any query, please unmute and please do not hesitate to stop me in between and get your doubts clear. Okay, sir, move to the next slide, sir, please. Okay, now one more example. That there is a relationship between age and exercise. Okay, exercise participation. So how to frame null and alternative hypothesis for this? Yes, sir, now I am able to share the PPT. So I'll take the control to my side now. Thank you so much, Giri sir. Okay, now there is one more example. We'll see there is significant relationship between age and exercise participation. This is alternative, and now here again there is no direction. Okay, whether the age and exercise participation or whether the age has positive impact on exercise participation or negative impact on exercise participation is not mentioned. So again, this is the example of non-directional hypothesis. Okay, so wherein the direction is not mentioned. Okay, now second example. Now here in alternative they have mentioned participation will significantly increase the exercise participation, or participation will not increase or will decrease the exercise participation. Okay, so now here the direction is mentioned, whether it is increase or decrease in number of participation, direction is mentioned. So it is called directional hypothesis. Now directional hypothesis is also called one-tailed hypothesis, and non-directional hypothesis is also called two-tailed hypothesis. Okay, so this is the example of two-tailed or non-directional. Directional hypothesis is called one-tailed because specific direction is mentioned here. Now I'll move to the next part, that is type 1 and type 2 errors. Now again, I'm repeating, the hypothesis is a statement of proposition, supposition, presumption, assumption, which will be disproved or disproved, okay, after the data analysis part. Now, when you assume certain uh, association between two or more variables, suppose we'll first try to understand what is type 1 error. All the statements, whether it is null or alternative, okay, these are assumptions. Now, when you are assuming certain thing, and suppose at the end, after the data analysis, researcher will accept or reject these statements. Okay. Now, type 1 and type 2, definitely these are errors. Okay. Errors means some mistake has happened. Okay. Type 1 error occurs when you reject the null hypothesis when it is true. Okay. Null hypothesis researcher has stated. Then after analysis, the hypothesis is or the statement of assumption was true, but by mistake the researcher rejected it. So such type of, that means error occurred. Such type of error is known as type 1 error, which is also known as alpha error. That means rejecting null hypothesis when it is true is called type 1 error. Type 2 error, accepting null hypothesis when it is false. Actually, the statement is false, but by mistake, the researcher accepts it. Such type of error is known as beta or type 2 error. Remember, rejecting null hypothesis when it is true is called type 1 error, and accepting null hypothesis when it is false is called type 2 error. Type 1 error known as alpha and type 2 also known as beta. Now type 2 error, type 1 error is also called as alpha, and also it is known as significance level or level of significance. Okay. Means that is nothing but probability of committing type 1 error. Okay. That is called level of significance. Type 1 error, you are rejecting null hypothesis when it is true, and probability of committing type 1 error is called level of significance. We'll see, this will be more clear when we'll, at the end, we will discuss one example. Then what all these errors or significance level is, we'll see in more detail by studying the example. Then for now, you just remember type 1 error occurs when you are rejecting null when it is true. Okay, and the probability of committing type 1 error is called significance level. And we will be mainly dealing with this type 1 error or significance level in the example. Type 2 error, as we discussed, it is accepting null when it is false. Okay, and probability of committing type 2 error is called beta or power of the test. Now, some most common values of these level of significance or alpha are 1%, 5%, and 10%. 1% is 0.01, 5% is 0.05, and 10% is 0.10. All mean one and the same. Now I'll see how to test the hypothesis. Okay, now these are the steps for hypothesis testing procedure. First one is state null hypothesis. We are going to see example on these steps also. Second step is, in the first step, you state the null hypothesis. Suppose you want to measure the performance, want to check whether the culture has significant or any training program has significant impact on employee performance or not. Then initially in null hypothesis, this is the first step, you will state that the training program, there is no significant impact of training program on the performance of the employees. Okay, this is how you will state the null hypothesis. Okay, then you will choose a test. Now, which test to apply, then again, it is different topic of discussion. So here, now to test these two variables, you need to choose a statistical test. There are different types of tests, and how to select test, again, it's different area of discussion. Third is, after selecting the test, you need to decide on the level of significance. Level of significance, as I told, it is probability of committing type 1 error. Okay, and most common values here are, means for academic research, for the student research, it is usually 5%. Okay, if not given, or whether it is given, you can assume it at 5%, that is point not 5. Then compute the test value. Now this is the test value. In second step, whichever test you select, okay, the test value is computed in the third step. Now from where to calculate the test value? From the given data. You see, based on the objective of research, you will collect the data from the employees. Suppose your research is related to the performance of the employees. You will collect the data from the company or from the employees related to their performance. And then you will calculate the test value. On different measures, you will see the performance of each employee. Okay. And here in the third step, in the fourth step, the test value is calculated. Now, the next step is obtain critical test value. Now, this is the threshold value. Okay. Now, for example, whenever you do any practical in the lab, okay, in simple words, I will try to explain this, what is critical value. Then you will see that beyond certain value, the values are not acceptable. That means you have made certain mistake in your practical, that you are getting wrong values. Okay. So in hypothesis testing also, there is one threshold value beyond, or that value will decide whether to accept the null hypothesis or reject the null hypothesis. Why we are doing or following these steps? We want to test whatever we assumed in the beginning of the research. Hypothesis is assumption. Okay. So whatever we assume, whether it is true or false. If it is true, we will accept it. If it is false, then we will accept alternative hypothesis. Okay. Then last one is interpret the result. Okay. Now after getting this threshold value, critical value, what you will check? Whether your calculated value in the fourth step, whatever from the data which you have received from the employees or the companies, and you must have calculated one test value. You will compare that test value with the critical value. Now, from where to obtain this critical value? Okay, you don't have to calculate the critical value. Critical value is, you can say, table value or theoretical value which is available. Okay, if you Google it, you will get the t-test. Suppose, for example, t-test is one of the tests. Okay, for what purpose it is used, we'll discuss. But suppose in the second step, you have selected t-test, and then from the employees data, you have calculated the t value, and then you are going to compare it with the critical value. Critical value you will get in the t table. Okay, you don't have to remember all the values in the table. No need to remember. You just have to learn how to find out the critical value from the table, how to get the value, how to check the value. Now from that table value is compared with the calculated value, and then you need to interpret the result. If that value goes beyond the critical value, beyond that threshold value, then you will reject the null hypothesis. And if it is within that region, then you will accept the null hypothesis. Clear? So this is how the testing procedure is done. It always starts with stating null hypothesis. Then you choose the text. You decide on the level of significance, which can be usually 5%. Then you calculate from the data which you collect from the respondents, you will calculate the test value. Then you will compare it with the table value or theoretical value, and then you will decide whether to accept or reject the null hypothesis. Hope it is clear to you. Now you'll see about the acceptance and rejection region. Now look at the first graph. Okay. Now the shaded region, Okay, shaded region is nothing but rejection region. I'll show you the diagram with, yes. Now look at the top left corner, the color diagram. Okay. Now see, the critical value is the threshold value, which is shown. Now see, this is the first image, colored image is for non-directional hypothesis. That means when the direction is not mentioned in the hypothesis, that means it can go both way. So the rejection region lies in on both the sides of this graph. Now this graph shows the distribution of the data. So when it lies on both the side, the rejection region for non-directional hypothesis. Okay, or you can say two-tailed, because two-tailed regions are there on both the side. If your calculated value in the fourth step falls in this region, then you will reject null hypothesis. But if it falls in rejection region, say in between two shaded region, there is acceptance region, or you can say non-rejection region. If your calculated value falls in this region, you will accept the null hypothesis. But if it falls in the shaded region, you will reject null hypothesis. For two-tailed or non-directional hypothesis, shaded region lies on both the sides. Okay, but for one-tailed hypothesis, it lies on only one side. But it will be either at the left, whether depending on the statement of your hypothesis, or it will be on the left side of the graph. Okay, either it will be on the right side or left side in one directional hypothesis or one tailed hypothesis. Now this shaded region, or and that is also called critical region. Look at the second diagram. It shows the critical region on the left side, this diagram. Okay, now the third one, this one shows on the right side. This is the right side. Okay, and the third diagram, it is non-directional, where the critical region lies on both the sides. Clear? So critical region or rejection region, it will be more clear to you when we'll say, see, look at this diagram. Okay, now the critical value is threshold value. For two-tailed, it will lie on both the sides. Now what is alpha in the diagram? Alpha is nothing but level of significance. Okay, level of significance, and the area under shaded region is alpha, and rejection region is always, the area under rejection region is always alpha. Non-rejection is 1 minus alpha. When the rejection region is on both the sides for say two-tailed or non-directional hypothesis, then the area under the shaded area, okay, or under rejection region is alpha by 2 to first left side and alpha by 2 to right side. Means half of the rejection region lies on the left side, half of the rejection region lies on the right side, and the area is alpha by 2 divided on both the sides. But in case of one-tailed test, the entire alpha lies either on the left side or on the right side, and non-rejection region or acceptance region is 1 minus alpha. That is the area under non-rejection region, or you can say acceptance region. This will be more clear when we'll try to solve one example. Clear? So how to start the statistical procedure? First, you will state the null hypothesis. Then second, statistical test you will choose. Third, decide on the level of significance. Fourth, calculate the test value. The next one is, one should obtain the critical test value and then interpret the result. Okay, so these are the steps. Now we'll see the example so that these steps will be more clear to you. And we'll see the acceptance and rejection regions. Okay. Now look at this example. Random sample of 26 sociology graduates scored 458 on GRE Advanced Sociology test with a standard deviation of 20. What is the question asked? Is this significantly different from the population average? Okay. Now, in the example, two average values are given. One is what the students have actually scored. Okay. And another is, say, you can say theoretical average. Now, to test whether the difference is significant or not, t-test is used. Okay. So for this example, t-test is used when you want to compare two average values. Okay. Average value 1, average value 2 from different population, or one can be theoretical and one can be actually which you calculate from the data of given sample. Okay. T-test is used when your sample size is less than 30. T-test is used when the data is normally distributed and randomly collected. So these are all few simple conditions when to use t-test. Okay. Now for this example, t-test is used. Now why? Because we want to compare two average values. One is the sociology score of 26 graduates. Now why t-test is applicable? First condition, you are comparing two average values. One is the average score which the sociology graduates have scored, and another is the theoretical. Some theoretical value is average value they have given in the example with which we will be comparing. Second thing, sample size is 26. Okay. I hope the concept of sample is also clear to you. So that's why here the t-test is perfect. Now look at these statements. Null hypothesis, it is a statement, but here they have shown it. This is one way of writing the null hypothesis. Now for this example, how to state null hypothesis? There is no significant difference in the sociology in the score of sociology graduates which they have obtained on GRE and the population average. Okay. This is how you will state. Means there is no significant difference means what? Both the scores are equal. Okay. Suppose mu is what in the example, in the statement of null hypothesis, if mu represents what is the score that those sociology graduates have or obtained. Okay. So 440 and 458. You are comparing mu with the theoretical mean, that is 450 they have given. Okay. So obtained score and the theoretical score, there is no significant difference. When I state like this, that there is no significant difference between the average scores which sociology graduates have obtained and the theoretical score. Same way, same statement can be represented with the equation which is shown on your screen. That is mu is equal to 440. Both are not, there is no significant difference means both are equal. And in alternative statement, there is a significant difference between the obtained score and theoretical score. Okay, that means both are not equal. Okay, clear? So how this is one way of representing the null and alternative. But usual practice, whenever you will solve such examples, always try to state the examples, okay, in terms of statements. Null hypothesis will be there is no significant difference between the score obtained by sociology graduates and the theoretical average. Alternative will be exactly opposite to this null statement. Clear? Now, after stating this hypothesis, what will be the next step? What is the next step? Decide on the test. Okay. So we have selected t-test because of these different criteria. When you are trying to compare the average scores of two groups, then t-test is used. So we have selected t-test. Okay. Then level of significance. Level of significance, I think, is not given in example. If not given in example, you will assume, okay, researcher will assume the significance level at 5%. 5% is 0.05. Level of significance is also represented by alpha. So alpha value here is 0.05. Now forget about this degree of freedom. What is degree of freedom? Is nothing but, now you will not go into the details of degree of freedom, but it is, these are the values, okay, which are free to change around. Okay, so here the formula is n minus 1. N is sample size. How many sociology graduates are given in the example? 26. So 26 minus 1, okay, is your degree of freedom. Now for what purpose we require, we'll see at the end. Okay, and critical value is stable value. Either it will be given in the example, or we'll see how to check this critical value in the T table. Now, this is formula which is used. What is the next step, which we have seen in the example, which have seen on in the diagram? Calculate test value. We are now on the fourth step. I'll show you the steps again. Yes. Okay. Now we are on the fourth step, compute the test value. Okay, now that here for this example we have selected T test. Okay, so here we will be calculating the T test from the formula. Okay, this is the formula which is used to calculate the T test, T value, or you can say test value. Okay, so here after putting all the values, we get the value of T as 4.5. Okay, 4.5 is the value which we have obtained, okay, from the given data. Now next step is obtain critical value. Now critical value, how to obtain? Now this is the T table which you will find at the end of any reference book or on the Google source. This is available, no need to remember it. Now tell me, this is one-tailed or two-tailed? This is two-tailed because direction is not mentioned. Okay, whether score is greater or say less than the obtained score is whether greater or less than the theoretical score. We are not mentioning the direction in hypothesis. We are just checking whether two scores are equal or not. Okay, so look at the row of two tails here. I hope you are able to see the cursor. Two tails made. This is the row which shows the value of level of significance. Now in this row, for our example, the value of significance which we have assumed is 0.05. So here is the value 0.05. Okay, that is 5% level of significance, and we are referring to two-tail. Now what is the degree of freedom? DF. See, look here. Okay, these are the values of DF. Now what is our degree of freedom value? It is 25. 26 minus 1 and minus 1. So this is 25. So you will look for this row and this column, 0.05. So the value of 25 degree of freedom and 5% level of significance, here we get, here is the value 2.060. So this is the value, which value? Critical value. Okay, now I'll see. Now our critical value is, we have obtained 2.060, but since it is non-directional, okay, direction is not mentioned, so this critical value will lie on both the sides, okay, positive as well as negative. So C is 2.060. Now what is your calculated value? 4.5. We have calculated value, test value is 4.5. Now to which side it lies? To the right side. But suppose this is the critical value over here, and if it lies over here, 4.5, whether it falls in rejection region or acceptance region? critical value is less than the calculated value. So T value lies over here. So whichever graphs we have shown, it will lie in rejection region. Okay. So if it lies in rejection region, we will reject the null hypothesis. So when we reject the null hypothesis, then last step is interpret the result. So how to interpret the result? Since the obtained value failed in the critical region or rejection region, so we reject null hypothesis because obtained value is greater than critical value and it lies in rejection region. So reject the null hypothesis. So what conclusion can we draw? That, see, you are rejecting null hypothesis means you are accepting alternative hypothesis, because alternative hypothesis is exactly opposite to null hypothesis. So we will accept the alternative hypothesis. What is the alternative hypothesis in this case? That there is significant difference among the scores obtained by the students. Okay, so that is the statement we will accept. Clear? Why we rejected it? Because as shown in the graph, it was in rejection region. Okay, if you see this graph, it was lying here in this rejection region. Two-tailed test, the calculated value. So we rejected the null hypothesis and we accepted the alternative hypothesis. Okay, for one-tailed test, you will always see there will the critical value will lie, it will be either left or right side. But for two-tailed test, non-directional test, it will always lie on both the sides. Okay, so this region is alpha by 2, this is alpha by 2, and acceptance region area is 1 minus alpha. So this way you will come to the conclusion or interpretation that one should accept or reject the hypothesis. Okay, so in the first step we started with the stating the null and alternative hypothesis. Then in second step we decided on the test, which test is applicable to the given data. Third step we decided on level of significance, that here in this case we assumed it at 5%. If it is not given in the state example, we will assume it as a 5%. Then in the next step we calculated the t value from the given data. Then we obtained critical value from the table. Okay, so here what you need to learn is how to read the table. In this example, these row values are significance values, level of significance. Here we checked for 5%, 0.05, and the column values okay, and the column values are the you will see this row degree of freedom 25 and the level of significance as 0.5, and here we got the critical value, that is 2.060. Okay, then we compared the obtained 4.5 with 2.060. We found that the 4.5 lies on the right side of the critical value, or it is greater than the critical value. We came to the conclusion that we should, since it lies in rejection region, we should reject the null hypothesis. So this is how we came to the conclusion. Okay, so for your research projects, this is one of the steps. After deciding your objective, you need to frame the hypothesis and you need to go for the data analysis part. Hope this session is useful to you in doing your field project or say research project or summer internship project. In all the three projects, to some extent, or for SIP, you require the entire hypothesis testing, or you need to include this part in all the projects. Yes, thank you so much, sir. I think we should time up. So can we continue or should we stop the session? Giri, sir?
Yes, ma'am.
Okay, so this is the end of hypothesis testing part. Hope students are able to understand to some level how to test their statements, how to frame the hypothesis, what are the types, and can go detailed. So maybe sometime on in the next session we can also focus on how to test using SPSS or the tools. Students, there are different tools available to test the hypothesis. Okay, so manually you don't have to calculate any test values or say uh, do any calculation, but tools are available. You need to learn to use the tools. Thank you so much, Giri sir. Thank you so much for and director sir. Okay, please, thank you so much for providing me opportunity to conduct this session, and I hope students enjoyed the session. Thank you so much.
Thank you, ma'am. Thank you for the enlightening session. Dear ma'am, on behalf of Matrix School of Management Studies, I would like to extend our sincere gratitude for your invaluable contribution as a guest speaker for the section on understanding basics of hypothesis for conducting research. Your session was highly insightful, engaging, and enriching for all our students.
Thank you so much, sir. Thank you.
Thank you.
Thank you.
Students, please share the feedback. Please share the feedback for the session. Don't let out without filling the feedback form.